All right, here are our 5-3 notes where we're going to be solving problems involving shapes, involving the properties of shapes that we talked about in 5-2. So you will definitely want to have your 5-2 notes out to reference while we are working on these problems. So first one we're going to do is, it is given to us that WXYZ is a parallelogram, and then they give us some information about our parallelogram. So we're going to be using our properties of parallelograms that we know. So XY, they tell us, is 15, WX is 22, and then Z to X is 52 all together. I'm not going to write that in my shape though because it's going to kind of clutter it up. And then WT is 23. So I'm going to solve my side lengths first, or my segment lengths first here. So properties of a parallelogram, we know that a parallelogram has opposite congruent sides. So we know that if WX is 22, then ZY is 22, and if XY is 15, then WZ is also 15. So we can fill that in over here. ZY is 22, and ZW is 15. And then we also know with a parallelogram that the diagonals bisect each other. So that means that each of the little halves created here are congruent. So WT would be congruent to TY, which means that W to Y altogether would be 46. And Z to X is 52. Well, we know that TX is going to be exactly half of that because the diagonals bisect each other, meaning they cut each other in half, right? That's what bisect means. So TX would be half of 52, so TX would be 26. Okay, so we finished our segment lengths. Now we're going to go ahead and solve our angles. So we have some angle measures given to us. We have that W to Z to Y altogether is 72, so that angle right there is 72 degrees. We have that WXT is 35 degrees. And ZWT is 59 degrees. Now what we know about the angles of a parallelogram is that opposite angles are congruent. So I know that if WZY is 72 degrees, then WXY is also 72 degrees. We know that opposite angles are congruent. We also know that consecutive angles are supplementary. So WZY is 72 degrees. WZY plus, so angle WZY plus angle ZWX is 180 degrees. They are supplementary. And then we also have some alternate interior angles, which we can keep in mind because we know that these sides are parallel because it's a parallelogram. So we should, oh, and then the other thing that we have in our picture here, you guys, is we have some triangles within our shape there. Those triangles, angles are always going to add up to 180. Okay, so let's see if we can figure out what these angles are. So TZY, measure of angle T to Z to Y, is this little space here, shaded in. Okay, that is TZY. Now I know that my alternate interior angle to that TZY is the 35 that's up here. Okay, those are alternate interior angles, so TZY would be 35 degrees. XYZ, X to Y to Z is, XYZ is this whole space here. And I know that that XYZ plus WZY needs to be 180 degrees together. WZY is 70, so XYZ is 180 minus 72, which is 108. So X to Y to Z would be 108 degrees. XWT is going to be 108 minus 59, which is 49 degrees. And XYT is going to be the alternate interior angle to that 59 degrees. Alternate interior angle to the 59. Right here is the alternate interior to to XYT right here. So XYT is 59 degrees. Okay, so I know there's a lot kind of going on inside that shape. If you have any questions about where I got any of those values, be sure to ask. Easiest way to do that would probably be to message me on Remind. Okay, so that is example 1, working with our properties of parallelograms. Example 2, we have a rectangle. So we're going to have all the properties of the parallelogram that we just did, and then we are also going to have some extra properties. Rectangle has the properties of a parallelogram, plus its diagonals are congruent, plus it has 90-degree angles for right angles. So we're going to work with our rectangle here, ABCD. DB, it tells us, is 42 units. I'm not going to put that on my shape, but D to B, my diagonal there would be 42. Okay, I know that my diagonals are congruent in a rectangle, so I'm going to go ahead and also identify there that A to C would also be 42, which is my first blank over here. A to D, AD is 26, so I know that BC is also going to be 26. I'm going to go ahead and put that on my shape there. I know that EB will be half of 42 because it is half of my diagonal, and my diagonals bisect each other. It's one of the properties of a parallelogram. And AB, so AB is actually a length. I don't think they gave us enough information for AB here. Yeah. So I think that is, oh, wait, correction. So what we have to do to solve for AB, okay, if I redraw just half of my rectangle here, then we have a right triangle, and this is the side I'm trying to solve for, right? I'm trying to find AB. I have A to D to B here. I know that D to B is 42, and I know that A to D is 26. I can use the Pythagorean theorem. You guys remember that? Pythagorean theorem will allow me to approximately solve for my length there. Pythagorean theorem is A squared plus B squared equals C squared. So X squared, what I'm trying to find, plus 26 squared, which is 676, plus 42 squared, 1764. Then I subtract 676 from both sides. I have x squared equals 1088. And I take the square root to make it just x. And I get that x is approximately 32.98. And we can go ahead and just leave that as a little decimal there. Okay, so AB is about 33. Remember, the little double squiggle means about. Okay, so we can use, because we have right angles all over our shape here, we can use the Pythagorean theorem to solve. And then we'll do our angles here. So we have that the measure of angle DAE is 52 degrees, and we know that each of our corners is a right angle. And just like we had in our other shape, we have alternate interior angles here. So we're going to have a lot of congruent pieces here. 52 degrees is also going to be here. 90 minus the 52 is going to be 38. 38. And then in the other angles here, because our diagonals are congruent and bisect each other, that means that we have 4 isosceles triangles, which means that our angles opposite of our congruent sides are also congruent. So again, a lot of congruent pieces in here. Okay, so we can see our 4 isosceles triangles there, right? For example, if you just look at that bottom triangle, we have 38 with 2 congruent sides. Opposite those 2 congruent sides are our 2 congruent angles. So ADC, angle ADC is 90. Angle ABD is 38. Angle BCA is 52 degrees. Angle DEC is this angle right here, which we're going to find by adding 38 plus 38 and taking that away from 180 because we have that triangle there. So I'll try it again. 38 plus 38, and we take that away from 180 degrees and we get 104 degrees there. Again, that's our triangle here, our bottom triangle where we have 2 38-degree angles. We know that this then would need to be 104 degrees. Okay, so there's our properties, using our properties of a rectangle. Now we have example 3, which is using our properties of a rhombus. Again, all the properties of a parallelogram plus the diagonals are perpendicular plus the diagonals bisect the angles. So those are our specific properties of a rhombus. So ZY is 34 degrees, or 34 units. That means that WX will also be 34. Okay, and then also I know that with a rhombus, my diagonals are perpendicular and my diagonals bisect my angles. So I'm going to add some markings in there just to remind myself what my properties of a rhombus are. WY is 38, which means that each of these pieces for WY are going to be 19 and 19. Okay, now what we don't know with a rhombus that we did know with a rectangle is that the diagonals are congruent. Rhombus, they're not necessarily congruent, but they do still bisect each other because that is a property of a parallelogram. ZXY is 34 degrees. Find the following values. So we have, we're looking for WZ. Okay, WZ with a rhombus, the other property that I forgot to mention earlier, a rhombus has 4 congruent sides. So that is where it differs from a rectangle sometimes. Okay, WZ, a rhombus, has 4 congruent sides, so all of our sides here are 34. Then VY we already identified would be half of 38 because our diagonal there is bisected. WXZ we know with a rhombus that our angles are bisected. So because we already know that ZXY is 34, then WXZ would also be 34 degrees. WVZ is one of our angles created by our diagonals, which are going to be 90 degrees in there because the diagonals are perpendicular. ZYW. So ZYW, the 34 plus the 34, so 68, which is our other angle here, plus angle ZYX needs to be 180. So remember, our consecutive angles are supplementary with parallelograms. So that means that angle ZYX would need to be 112, and then we can divide that by 2 to get each of our little pieces there. 56 degrees are going to be the measures of our other angles here. So 56 here, 56 here. So ZYW would be 56 degrees. And XYW would also be 56 degrees. Okay, so rhombus has perpendicular diagonals and 4 congruent sides, and the diagonals bisect the angles. ABCD is a square, so it's going to have all the properties of the shapes that we've done so far: parallelogram, rectangle, and rhombus. So ABCD is a square, AD is 11. That means each of our sides are going to be 11. And then what's nice about a square is that the diagonals are perpendicular, it has 4 right angles, and the diagonals bisect each other, so each of our angles in here are 45 degrees. A lot of congruency in squares. So BC is 11, A to C we need to solve for. So A to C is our diagonal of it's our hypotenuse of our right triangle created by ABC, where we have 11 and 11. So we're going to do 11 squared plus 11 squared equals C squared, or X squared, right, what we're trying to find. That is 121 plus 121 equals C squared. So 242 equals C squared. So our diagonal there, AC, is approximately the square root of 242, which is about 15.6. And then BD would be the same, because with a square, those diagonals are going to be congruent, property of a rectangle, which a square also has. DAB is a 90-degree angle. AEB is a 90-degree angle. CBD is a 45-degree angle. And BAC is also a 45-degree angle. Okay, example 5, MNOP is an isosceles trapezoid. That means we have 2 congruent legs here, MP and NO. So if MP is 16x minus 13, and NO is 9x plus 8, then we can solve for x by setting those equal, because we know it's an isosceles trapezoid. So 16x minus 13 equals 9x plus 8. And then we solve by adding 13 and subtracting 9x. It's going to get my x's to cancel. I'm going to have 5x here. 5x, 7x. Sorry. 7x. My 13's cancel, and I have 21 here. Divide by 7, and I get x equals 3. Okay, so that's part of what they asked me to solve for. They also asked me to solve for y in an isosceles trapezoid. We also know that the diagonals are congruent. That's a property that it shares with rectangles. So PN is one of its diagonals, and that is going to be congruent to the other diagonal, MO. So we can set our y expressions equal, and then solve for y. I'm going to subtract 5y and add 37 to get my y's on the same side and my numbers on the other side. 19 plus 37 is 56. 12y minus 5y is 7y. Divide by 7, and I get 8 equals y. Okay, so solve for x, solve for y. Isosceles trapezoid has congruent legs and congruent diagonals. For trapezoid PQRS, x and y are midpoints of the legs. That means that YZ, you guys, is a midsegment. So this is where we're going to use that midsegment equation that we wrote down under our properties of trapezoids, which is that one base plus the other base. So 38 is one of my bases, PQ. X plus 14 is my other base. If I add the two bases together and divide by 2, then I get my mid-segment. Okay, which means that, so if I need to solve this for x, first thing I'm going to do, you guys, is get rid of my fraction. I'm going to multiply everything by 2. Okay, on this side, it's going to get rid of my fraction, so I will just be left with my numerator. And on the other side, I'm going to end up with 10x minus 38. Now make sure here that we double both pieces. Okay, then I'm going to get my x's on the same side, and I'm going to combine these like terms here on my left side. 38 plus 14 is 52. So I have 52 equals 9x minus 38. Then I'm going to add 38 to both sides. So I get 90 equals 9x divided by 9, and I get x equals 10. Not what it asked me to find. It asked me to find yz, so make sure we always go back and check. So I found x, so then I can plug 10 in for x to my yz expression. That gives me 50 minus 19, which is 31. So yz equals 31. Here's my answer. Okay. So last couple questions here, you guys. This is a parallelogram, though it doesn't tell us that. I'm telling you that. Okay. Parallelogram. Okay, that means that opposite angles are congruent. So 6x minus 15 equals 4x plus 11. And then solving for x, I'm going to get my x's on the same side and my numbers on the other side. So I get 2x equals 26. So then x equals 13. Okay. However, that's not what it asked me to find. So I'm going to plug 13 in here for x. That is 6 times 13 minus 15. 6 times 13 equals 78. Minus 15 equals 63. So the measure of angle A is 63. Well, I know that the measure of angle A plus the measure of angle B needs to be 180. So these two added together needs to equal 180. So if this is 63, then I go 180 minus 63, and I get that the measure of angle B is 117 degrees. Okay, and then my last one here, as we talked about up above, we're going to have some alternate interior angles within our parallelograms and rectangles. Rectangles because it's a parallelogram. So 7x plus 5 equals 11x minus 3. This is going to allow me to solve for x. Again, getting my x's on the same side and my numbers on the other side. I get that x equals 2. I'm going to plug that in here. 11 times 2 minus 3 is 22 minus 3. So that angle is 19 degrees. Okay, that is this angle here shaded. But then it asked me to find BCE. BCE is the other side of that angle. And I know this is a rectangle. So that means that this whole corner is a 90-degree angle. So to find BCE, I'm going to do 90 minus 19. 90 minus 19. Whoops. 90 minus 19 is 71 degrees. Okay, so I know we kind of quickly through those last ones. Just trying to keep the notes a little bit shorter for you guys. But a lot of properties. Again, make sure you have your properties out and referencing them as you're working on these problems. So hopefully we can start recognizing which properties are distinct to which shapes. Let me know if you have any questions.